Okay, here's a sort of a basic review about the kinetics of SN1 reactions. So when people determine the rates of an SN1 reaction, they basically said that, well, we know that the rate equation should look something like this. The only question is, what would be the exponents? What are the orders of alkyl halide and nucleophile? And so what they did was they basically ran reactions with different concentrations of alkyl halide and nucleophile and then determined the rates. And so I'm just going to make some up, but this will illustrate how they got the overall rate equation. So what they said was, let's react 1 molar and 1 molar, and they got a rate of, let's say, 10. And then they doubled the concentration of the alkyl halide while holding the concentration of the nucleophile the same, and they found that the rate doubled. And so that tells them that it was first order in alkyl halide. And so the overall rate equation would equal K times concentration of alkyl halide to the first power. Then what they did was they decided to hold the concentration of the original solution alkyl halide, but double the concentration of nucleophile. So we're comparing these two experiments, and what they found was that the rate didn't change. And they went on and said, okay, well, let's triple the concentration of nucleophile while holding the alkyl halide the same, and the rate didn't change. And so that means that the concentration of nucleophile in this rate equation is to the 0 power, because anything to the 0 power is 1. So overall then, the rate equation had to be the rate constant times the concentration of the alkyl halide to the first power. Okay, and that was what they that's what they determined it to be. So the nucleophile did not play a role in the rate equation. So then in terms of developing a mechanism, what they decided to say was, well, step 1, your alkyl halide breaks the carbon-halogen bond, forms a carbocation, and the leaving group anion. That's rate number 1. Now, if you go back to general chemistry, what you learn is that for the overall, this is all the overall rate equation, that for the overall rate equation must come from data. You must use data to determine the overall rate equation, which they did. But if you have a mechanism, and each one of these are what are called elementary steps, that for an elementary step of a mechanism, you can write the rate equation for the elementary step using the stoichiometry, using the stoichiometry of the balanced equation. And so in this case, we can write the rate equation of that reaction by saying there's a single molecule of alkyl halide. That would be the rate equation of the elementary step. Then in the second step, they determined, they proposed and ultimately determined that that's where the nucleophile reacts with the alkyl halide to form the final product. And in that case, we would say that the rate equation would be the concentration of the carbocation to the first power times the concentration of the nucleophile to the first power. Well, in this case, since the overall rate equation doesn't have the nucleophile concentration in it, that identified the first step as what we call the rate determining step. So that the overall rate equation, the overall rate equation has to match the slowest step in the mechanism, and so that was the first step. So the first step in this reaction is the slow step. The second step is the fast step. And so since these two rate equations match up, that indicates that the first step would be the rate determining step. So in the kinetics, the concentration of the nucleophile does not play a role. The concentration of the reaction of an SN1 reaction is only determined on the concentration of the alkyl halide. And why is it an SN1 reaction? The SN1 stands for unimolecular. And in this case, the unimolecular reaction means that there is one molecule reacting in the mechanism. And so that is, again, the first step in the first elementary step in the mechanism. So whereas SN2 has the concentration of the alkyl halide and the concentration of the nucleophile in its rate equation, the unimolecular SN1 only has the concentration of the alkyl halide. Okay, and that's important if we look at problem number 2 here, where it says, what is the rate law for this reaction? In this case, the rate law is to take the tertiary butyl bromide, react it with H2O. Acetone is the solvent, so it doesn't play a role. Since this is a tertiary halide plus a weak nucleophile, that will make the reaction SN1, which they've told you. And so the rate equation is rate equals rate constant times the concentration of the alkyl bromide to the first power times the concentration of the water to the 0 power, which means that it's just dependent on the rate of the alkyl halide. And so in this case, it would be number 1, and solvent does not play a role.